Hello everyone, welcome back to the channel. In today's video, we are going to cover some core system design concepts that are extremely important for computer science students, IT students, and for anyone who is preparing for technical interviews. So as I said, we are following the system design interview book written by Alex Yu. And in today's video, we are going to focus on three main topics. They are databases, vertical and horizontal scaling, and at last about database replication. So these concepts explain how real-world systems scale from a single server to millions of users. And let's get started. In the first topic related to databases, we need to know that as our applications grow, one server is usually not enough. Then a common design pattern is used to separate the system into two layers. So they are the web tier and the data tier. The data tier is usually also known as the persistent layer. And to know each layer in the web tier, that is the area which handles the requests that are coming from the browsers and mobile apps. And the data tier handles the data storage using a database. Right. So this separation allows each layer to scale independently, which is a key idea in system design. Now we are going to look at the types of databases and which databases to use. So there are two major categories of databases. The first one is relational databases, which use SQL. They are also called as RDBMS or SQL databases. Few examples are MySQL, Postgres, and Oracle. So the key characteristics of relational databases are the data is stored in tables and rows. You can use SQL queries and it supports joins across multiple tables. And also they have strong consistency and a structured schema. So they are usually the default choice for most of the applications nowadays. And the second type is non-relational databases, also known as NoSQL. So these are commonly, they are called as NoSQL databases. The popular ones are CouchDB, Neo4j, Cassandra, and DynamoDB. They are very useful when you need to have very low latency, when your data is unstructured or semi-structured, and also when you need to store JSON or key value pairs, and also when you have to handle a massive amount of data. So choosing between SQL and NoSQL depends on the application requirement, and it is not based on the popularity. Okay, so now we are going to look at the second part, which is vertical scaling and horizontal scaling, uh, which basically means handling more traffic and handling more users. Vertical scaling is also known as scaling up, which means adding more power to a single server. For example, we are going to add more CPU, more RAM, and faster storage. The advantages of this is that it is simple to implement and good for low traffic applications. And the limitations of this are uh, is that there's a hard limit on how much you can upgrade one server. And also there is no failover because there is only a single server, and when it goes down, the entire system will go down. And the other method is horizontal scaling, which is also known as scaling out. That means we are going to add more servers into your system. Instead of one powerful server, you may have many smaller servers working together. And the advantage here is that it is better with fault tolerance, it has higher availability, and also it is ideal for large scale applications. This is where the load balancers come into play. So if we look at load balancers, they are going to receive requests from the user and distribute them across multiple web servers. So when we scale out horizontally, we are going to have multiple web servers, and the load balancer is the one which distributes the request among these servers. So it prevents the overload on a single server. And if one server goes offline, the traffic will be automatically redirected to the healthy servers. So this makes the system more reliable and scalable. Okay, now we are going to look at the final part, which is database replication. So far we have learned how to improve the web tier, but we need to know how to improve the database tier as well. Uh, if you are going to have only one database, then it becomes a single point of failure again, and that is the point where database replication comes in. So in database replication, it means that we keep copies of the same data across multiple database servers. The most common model is the master-slave architecture. Yes. In the master-slave model, what we do is uh, the master database will handle all the write operations, insert, update, and delete operations. And we keep a slave database, which is usually used for the reading operations. The slave database will always receive replicated data from the master. Since most of the applications have more reads than writes, this model works very efficiently. So, if we look into the advantages of database replication, there are few, like they will have better performance. Read operations are distributed across multiple slave databases, and it also have high availability, and also it will have high reliability, reducing the risk of data loss. When it comes to the failure scenarios, we can look into some real world scenarios. If one of the slave databases fail, reads are redirected to the other slave databases, and yeah, I will show like if this one fails, the read request will be redirected to one of these. So we avoid the single point of failure in this scenario. Uh, then we can slowly replace the failed slave database. If a master database fails, a slave can be promoted to become the new master, and the write operations can be received on that new master. In real production systems, this process is very complex and requires careful data synchronization. Finally, uh, here's how everything works together. So first, the user request will go to the uh, load balancer. Then it accept the request and it will distribute or forward the request to the web servers, which is the web tier. Then the web server will read the data from the slave database, or if it is a write request, it will write to the master database. Then the data is replicated between the master and the slave databases. Uh, s- this architecture allows systems to scale from zero to millions of users. To summarize the concepts that we learned today, databases store and manage application data. Vertical scaling has limits and some risk involved in that. Also, horizontal scaling improves the availability and performance. Then, database replication ensures reliability and scalability. These are the foundational system design concepts that we will see in the real world systems and also during interviews. If you find this helpful, don't forget to like, subscribe, and also to share. Okay, guys, thank you for watching, and I'll see you in the next video.